Hey guys, we're going to be learning about function notation today. So this should be the first screen on your Desmos. So we're going to do a quick recap from the other day. So here's a graph from the function Carnival. It was an activity that we did something, we did this activity about a couple days ago, and we looked at race cars, we looked at a carnival, we looked at this guy jumping out of a cannon. So as you can see, this is a story, and we created a graph based on the story. So what we're going to do is go to the next slide. So we're going to observe first. So in a second, I want you to click the Add Label button and then watch the graph. When you think you understand what is changing or what the numbers mean, you can continue to the next slide. So if I push this, you can see that there's two sets of numbers, one in the X and one in the Y. What do you think those numbers mean? Okay, so remember, we're going to move to the next slide once we think we know what they mean. And it's okay if you don't. Remember, we're just learning. So we're going to explain what it means in words. There is an interesting point on this graph right here. What do you think the numbers 5 and 12.3 tell us about the Cannon Man? So I know that my x-axis, it says in time in seconds, and my height in feet. So I know that the number 5 tells me 5 seconds, or you can say 5 means he is at 5 seconds through his story or something like that. And the 12.3 tells me his height. I believe it is from the ground. Let's see. Height in feet. So probably how high he is, probably from the ground. In feet. Okay, then you can hit share with class. Once you do, there will be other responses as you go through this. Moving to the next slide. So we're on slide 4 of 14. We said that 5 is 5 seconds and 12.3 tells me his height. So now we're actually going to zoom out and find out. Wow, interesting. We were right. So remember, x-axis is time in seconds and the height in feet, how high he is, probably from the ground. Most likely, because he's a parachuter. So now we're going to drag the 3 points anywhere we want on the graph, and you're going to have to explain them. So take a second, move a couple of these points, and type in what each of those numbers mean. So I dragged my 3 points randomly somewhere. Yours don't have to match mine, but what does need to match is which one is seconds and which one is height. So remember, your first number here, mine is 2.7. That's at how many seconds has happened. And he was at 32.103 feet. At 4.3 seconds in mine, he was at 22.919 feet. And at 8.9 seconds, he was at 2.706 feet. So remember, you can drag any of these anywhere. My suggestion would be not to use 0, 0, because that one's pretty easy, and not use the one right here that we just did. So you're going to click share with class, make sure that you share with the class, and hit the next button. So looking at the next screen, it'll tell you what you wrote on the previous screen. Okay, in mathematics, we might write the same information using something called function notation. It's a lot easier to write instead of writing out this whole sentence of at 2.7 seconds he was this much height off the ground. You know, who has time for that? So if we look here, my 2.7, as you can see, that is my x. So anytime we have f of a number, that means on my x-axis at 2.7, what does my y equal? What is my other point? So remember, we have x's and y's. So if you see a number that says f of x 2.7 equals with a blank, what you're going to do is go to 2.7 and you're going to go all the way up until you see where your y is. Remember, this is just another way to write x and y. So at 4.3 seconds, we can say he's at 22.91 height, and at 8.9, he is at 2.70. So obviously your numbers are going to be here differently because you chose different numbers, but that's all right. So we're going to continue to look at this and get more of an understanding. So if you don't understand that this is x and this is y, that's okay. You'll see in a second what's going to happen. So now we're on the 7th slide. We're going to translate another words that a student described. After 8 seconds, Cannon Man was 4.92 feet off the ground. So how we would write that in function notation. Function, so f of 8, because that's how many seconds there are. That's my x. I'm going to end your parentheses, put equals, and at 8 seconds, how high is he off the ground? 4.92. And you don't have to put feet. Don't put feet. Okay? So this says my function at 8 seconds, he will be at 4.92 feet. So make sure you hit share with class. And let's move on to slide 8 here. So at this time, you are going to sort these cards into groups of 3. My suggestion would be to line up your graphs at the top. The reason why is because then you can see the actual points of where they're asking you to look. So like down here, this is about 8. So this one's a little bit longer than 8. And this one is a little bit more closer to maybe like 2 or 3. And this one's after 4, and then this one is before 1. So what you can do is you can definitely zoom in on these pictures. You can double click it and see if you open it up, just in case you can't read it. So what you're going to do is match the words and the equation, the function notation, to each of these graphs. So go ahead and do that now. All right, you should have matched at least your story to the graph. So the one that looks like this, that has 8 and then 4.92, 8 seconds after he launched, the Cannon Man will be about 5 feet off the ground, which is what this is stating. Same thing with this one, and this one. So take a brief moment and make sure that these match yours. So now that you have matched them, what you're going to do here is you're going to match these functions with the stories. Remember, the f of a number, that's my x. So this says f of x at 5 seconds, he will be at 12.3 feet. So you need to find one that matches it and pair them up. So go ahead and do that now. So this is what it should look like now. Okay, after 8 seconds, so the function 8 equals 4.92. The function 9.187 equals 2. The function 2 equals 29.52. Oops. The function 5 equals 12.3. And then function 0.3733 equals 8. So all of these should match and you should be good to go. Let's go to the next slide. So consider the advantages. Slide 9. In words, we might say after 7.5 seconds, Cannon Man was 6.15 feet off the ground with the function notation f of 7.5 equals 6.15. What is the advantage of words and what is the advantage of the function notation? So I want you to write what is the advantage of writing it out in words? 1. And 2, what is the advantage of just having it as sign or function notation right here? So what is the difference? What are the advantages? What would be just the advantages? So go ahead and start typing. So here would be kind of my explanation. In words, it'd be easier to explain it in words when pointing to it on the graph. So if I was going to say here, and I said at 7.5 seconds, the Cannon Man will be at 6.1 feet off the ground. But when we're looking at it on a graph, or trying to graph it in general, we can clearly see what his height will be at that time. Okay, so now we're gonna shift gears and we're gonna also explore the relationship between the green cart, right? Remember when we looked at the Ferris wheel? Now we're gonna look at the cart's height and time for this one. So if f of 5 equals some number, what is gonna be that number? Well, I know that this 5 says at 5 seconds, I need to figure out what the height is. So I'm gonna drag it and I'm going to go all the way to 5, as close as I can get. So at 5 seconds, the Ferris wheel would be at 8 feet. So you can just type 8. So at 5, at function of 5, my height will be 8. Okay? Make sure you hit share with class. Remember, I'm not hitting share with class because I'd be just sharing all the answers with you before you look through it. So now, number 2, if I needed to figure out how many seconds, because it says I don't know how many seconds, how tall the Ferris wheel will be at 12 feet, what I'm going to do now, instead of looking for 12 or a number here, I'm going to be looking for 12 in the Y category. So my height, I need to look at where it's going to be at 12. Oh, there we go. So it's going to be at 12 at 5 or 2.5 seconds. And let's see if there's any other ones. Because sometimes there's 2, sometimes there's 3. Oh. Nope. Looks like there's only 1. Looks like it's pretty darn... Oh, wait, there's 2. There it is. And 12.5 seconds. Okay, so that's where both of those, both of the Y12s will hit. That's the height. At 12 feet, we will be at 2.5 seconds and 12.5 seconds. So Alfie claims that f of a at 9.3 has multiple solutions. This person claims that at 9.3 feet, we can have multiple times. But Iris claims that at 9.3 seconds, I can have multiple solutions. So who do you think is right? Take some time, run through it, and test it out and see. Now that you've tested it out, the answer, let's see. I can go 11. Oh, look, 9.3. Pretty darn close. Back up a little bit. So 9.3, about. So I have 1 time. I can have 2 times. 3 times. So I could have multiple ones. So Alfie is correct. And Iris is not. Because look, at 9.3 seconds. At 9.3 seconds, I can only have 1 solution. There's only 1 time that's at 9.3 seconds. So we're going to pause right there and we're going to have a second little mini video for the last few slides.